Hello everyone. In this session, we are going to look at equation of continuity. Now, it's a very important part of fluid mechanics, especially the dynamics part of it. Actually, equation of continuity is a very simple conservation of mass statement. What it says is the mass entering this pipe must be equal to the mass coming out of this pipe for a given interval of time. That is it. So mass entering per unit time must be equal to mass leaving out per unit time. Now, let's say in a time interval delta t, this much of fluid has flown inside, okay? In time delta t, this much fluid moved in, this shaded part. Whatever is the volume or the mass of this fluid, the same mass has to come out. Why is that? It's because if someone says that a lesser amount of mass comes out than it goes in, that means slowly the pipe will start bulging because more mass is going in and less mass is coming out. So to maintain a steady flow so that the pipe does not bulge, to maintain a steady flow, we need to ensure that the mass entering must be equal to mass leaving out, and that is what gives us the equation of continuity. The final expression would be this. We are looking at its derivation, right? And what if the mass entering is less than the mass coming out? What would happen then? Then the pipe, with time, it will start shrinking because more and more fluid is coming out and less fluid is going in. So the pipe will kind of shrink. But that does not happen in a steady flow. That's why this stays valid. All right. Coming back to writing the expression for mass. How much mass is entering? If it is given that this cross-sectional area is A, and the density of the fluid, you can say the density here is ρ1 and the density here is ρ2. So mass is given by density into volume. And how much is that volume? It's going to be this cross-sectional area into, let's say this distance is delta x1. Is it not? So we will say A1 delta x1, right? And all this is happening in a time interval delta t. This is equal to the mass leaving out. How much is the mass leaving out? It's the density ρ2 multiplied by V2. V2 is this area of cross section A2 multiplied by delta x2, where delta x2 is this length. This divided by delta t, because all this is happening in some time interval, the same time interval for both. Now, if you look at this, we're almost there. Delta x1 upon delta t. Do you recognize this quantity? This is what we know as V1, or the velocity, yeah? Distance upon time, displacement upon time, that's the velocity. Similarly, this would be V2. This would be V1. And what we have is ρ1 A1 V1 equal to ρ2 A2 V2. This is the proper form of equation of continuity. But you would say that in the final expression, where is the ρ? Where is the density? So actually, this is a special case of incompressible flow. Incompressible flow means the liquid is not getting compressed. That means the density is staying constant. If that is the case, the densities will cancel out and you'll get this. Okay, so this is the equation of continuity, and this is how we get it. What is equation of continuity? Very simply, it's the conservation of mass, the statement for conservation of mass. Okay. All right. Let's now use this concept to solve a question, a previous year's JEE Mains question. All right, so here's the question. Pause the video, try it on your own, and then only look at the solution. Okay, since you have given it a try, let's now look at the solution. We have a pipe. The area of cross-section at both the ends are different. The tube of length L, so this length we'll consider as L, is shown in the figure. The radius of cross-section at the point 1 and point 2 is given. So R1 is given to us as 1 centimeters. Sorry, R1 is 2 centimeters and R2 is 1 centimeters, respectively. If the velocity of water entering at point 1 is given, so V1 is also given. V1 is given as 2 meters per second. Then the velocity of water leaving point 2. So that means we have to find V2. Pretty simple. Now we have to just apply equation of continuity directly, and that is A1 V1 equals A2 V2. Remember, A is area, V is velocity. Area for the first case, it's going to be pi r square. Let's write 2 centimeters whole square. V1, we already know it's 2 meters per second. Now, A2. What is the value of A2 here? A2 is 1 centimeters. So the area, the radius is 1 centimeter. So area would be pi 1 centimeter whole square multiplied by velocity. This is what we have to find out. You solve this, you'll get the answer. Now, one would say, why did I keep this as centimeters, this as centimeters, where this was in meters per second? Why did I not convert it into meters? Well, you could do that, you would get the same answer. Reason being, this was also kept in centimeters and this was also kept in centimeters, okay? As long as I'm multiplying or dividing by the same factor on both the sides, my answer should be fine. Okay. So if I quickly calculate this, I get V2 as 8 meters per second. So the answer would be option